This naturalrefrigerants.com article is being read by an automated voice. ATMO America. Simplify CO2 systems to drive uptake in the U.S., says founder of Future Green Now. By J. O. Harrelson. Published June 19, 2025. Simplifying CO2 systems with controls focused on annual performance rather than peak operating conditions will naturally drive the uptake of CO2 refrigeration in the United States, said Wyman Gronewald, founder and CEO of Future Green Now. Gronewald, who has 18 years of experience working with CO2 refrigeration systems, highlighted the benefits of the natural refrigerant using real-world examples in a keynote address at ATMO America 2025. The event, organized by Atmosphere, publisher of naturalrefrigerants.com, was held June 11th through 12th in Atlanta, Georgia. The systems we did 18 years ago were super complex, with unnecessary safety and backup features, Gronewald said. However, we've learned that simplified systems optimized for annual temperature conditions and integrated with HVAC applications take advantage of CO2, making it cost-competitive, energy-efficient, and user-friendly. Future Green Now, a natural refrigerants refrigeration consulting firm headquartered in South Africa, has worked on CO2 installations in Australia, New Zealand, Europe, North America, South America, and Saudi Arabia. One project highlighted by Gronewald included a 5.28 megawatt, 1,501-ton refrigeration, transcritical CO2 system commissioned in February 2021 for an 11,000 square meter, 118,400 square foot. South African storage facility owned by Precool Cold Storage in partnership with the shipping giant Maersk. Real-world examples. To highlight the economic benefits of CO2, Gronewald shared data from two transcritical CO2 installations, each supporting 19,500 square meters, 210,000 square feet, facilities with medium temperature and low temperature capacity. Both facilities, owned by the same company, used adiabatic gas cooling with water reclaim, heat reclaim, and hot gas defrost. The first facility had an 850 megawatt hours, 249 kilowatts, 70.8 tons refrigeration, megawatt capacity at a sea surface temperature of 23 degrees Fahrenheit, negative 5 degrees Celsius, a 220 megawatt hours, 65 kilowatts, 18.5 tons refrigeration, megawatt capacity at a sea surface temperature of negative 22 degrees Fahrenheit, minus 30 degrees Celsius, and a heat reclaim capacity of 150 megabritish thermal units, 44 kilowatts / 12.5 tons of refrigeration, at 130 degrees Fahrenheit, 54.4 degrees Celsius. It cost 10% more than a comparable HFC-based system to install but reduced energy consumption by 35%. The second facility integrated HVAC heating, cooling, and dehumidification into the design, with an MT capacity of 780 megabrits per hour, 229 kilowatts, 65.1 tons of refrigeration. At 23 degrees Fahrenheit, LT capacity of 250 megabrits per hour, 73 kilowatts. At negative 22 degrees Fahrenheit, heat reclaim capacity of 150 megabrits per hour at 130 degrees Fahrenheit, HVAC cooling capacity of 4,480 megabrits per hour, and 1,313 kilowatts per 373.3 tons of refrigeration. At 41 degrees Fahrenheit, 5 degrees Celsius, and HVAC, heating and dehumidification capacity of 1,500 million British thermal units, 440 kilowatts per 125.1 tons of refrigeration, at 104 degrees Fahrenheit, 40 degrees Celsius. The second installation cost 15% less than a comparable HFC-based system, with a 25% reduction in energy consumption. Cutting complication. CO2 systems focused on a set control point lower costs with less to go wrong, making it easier to teach technicians, Gronewald said. Let's cut costs and design CO2 systems for low-hanging opportunities. A common liquid line and a loop system reduce the pipework, cutting costs as does optimizing the number of evaporators, according to Gronewald. I've seen plenty of 5-year-old CO2 machine rooms with parallel compressors with only 100 hours of operating time, Gronewald said, while highlighting unnecessarily high installation design costs. Addressing misconceptions, we need to combat CO2 fear-mongering, Gronewald said, adding that it is just a refrigerant like any other. Unlike synthetics, CO2 is a single chemical with no glide. The high side of a CO2 system requires high pressure and flash gas bypass valves. However, the operation on the low side always stays the same. If you take into account that a CO2 system's capacity varies with ambient temperatures, you can control superheat without complex measures, he explained. The demand for CO2 refrigeration has increased the component supply to reduce installation costs, according to Grunewald. CO2 also offers lower operation and maintenance costs than synthetic systems. Quotable: "We need to trust CO2 as a stable, versatile refrigerant," Grunewald said. "The simpler the CO2 system design, the easier it is to install, operate, and maintain."